Welcome. Today we will be discussing our migration of a sizable and live Cloud Foundry in the public cloud over the past year, how we approached the migration, and the lessons we learned along the way. Hopefully you can relate to some of the challenges we were faced with, and you're able to leave the presentation with an understanding of some of the technical decisions we made. My name is Stacy, and I'm a software engineer at Liberty Mutual.
And I'm Tom, and I'm a senior cloud engineer at Stark & Wayne.
Today we will dive into the background of both Liberty Mutual and Stark & Wayne, Cloud Foundry's footprint at Liberty Mutual, the decisions behind the migration, a little bit about our Cloud Foundry customers, some of our pre-migration tasks, what migration day actually looked like, and where we are today. Liberty Mutual is the sixth largest property and casualty insurer, and our purpose is to help people embrace today and confidently pursue tomorrow by promising protection for the unexpected, delivered with care. Liberty Mutual has nearly 45,000 employees across the globe, 5,000 of which are in technology. Our Cloud Foundry platform team has 8 engineers across 2 time zones. Some of us are located on the East Coast, a few are in Wisconsin, and 1 is in Indiana. We support about 12,000 applications running on Cloud Foundry, with 3,000 average daily deployments and about 2,000 developers.
Stark & Wayne is a consultancy that specializes in Cloud Foundry, Kubernetes, cloud native, and serverless technologies. We've been consulting for close to 8 years now, and we've worked with many Fortune 500 companies to better enable their cloud native DevOps teams. I was the primary consultant with Liberty Mutual, and I've worked with them for the past year or so.
Now that you know a bit more about us, I'd like to describe Cloud Foundry's footprint at Liberty Mutual. The 12,000 Cloud Foundry applications running at Liberty Mutual run on various frameworks, which we maintain and support several build packs for. But as you can see, the majority of our Cloud Foundry users employ Java as their primary language. We also manage about 1,500 RabbitMQ and Redis service instances. And we support 12 foundations across 5 regions, of which 7 are in the public cloud and 5 are on-prem. We also have a lab environment that is not customer-facing within each, 1 in public cloud and 1 on-prem. Our largest foundation contains over 50% of our workload. At the beginning of the pandemic last year, our team came up with this idea that we could potentially migrate our Cloud Foundry platform to open source. Collectively with our management, we wanted to assess if it was feasible and/or viable. First of all, can we even do this? The idea and the decisions we needed to make turned into several lengthy discussions amongst the team that at times got heated. How do we build confidence amongst our users, even amongst ourselves, and especially within our management? We approached management with the idea, and they were eager and excited about the potential to pull this off. They immediately encouraged us to go for it and supported us with whatever we needed. The first decision they helped us make was bringing on Stark & Wayne.
We were brought on to teach the team how to build out, instrument, and maintain several scalable Cloud Foundry foundations. Together, we worked on getting the platform team up to speed and on the toolkits required to do just that by working with them on each aspect of the build-out, allowing each team member hands-on keyboard experience and collective troubleshooting when needed. We also wanted to work with the team in order to construct a migration plan that fulfilled their requirements for application downtime and developer impact with as little complexity as possible. Early discussions about the migration plan began with what our overarching strategy to perform the migration would be. The least complicated strategy from the operator perspective would be to simply build a new Cloud Foundry and enable Cloud Foundry users to migrate their applications to the new Cloud Foundry on their own time as easily as possible. This approach has the benefit of being simple and intuitive, as well as requiring little work during low-impact change windows. We were referring to this strategy as a new city migration. Conversely, a more operator hands-on approach to migration involves taking a snapshot of the existing platform and importing it to a target platform during a change freeze. We can achieve this with 0 Cloud Foundry user involvement, but because we're enacting a change freeze, much of the work needs to be done during a change window. The methods required for consistently snapshotting a live Cloud Foundry are also more technically complex than the alternative. We were referring to this strategy as a snap migration.
We felt conflicted on this decision in the early discussions we had, and the team had several discussions around the realities of each. The new city option seemed safest, but difficult to accomplish within a reasonable amount of time. And the snap migration felt overwhelming and intimidating, especially if we had no room for error, but it seemed more likely to be completed within a specific time frame. We had some additional decisions to make internally, like which foundations do we want to tackle first? Do we want to start small where there's least impact and try to learn and understand all the new concepts? Or do we want to start in our largest foundation with over 50% of all Cloud Foundry workload and figure out all our problems at scale right up front? These are all questions we tried to answer by understanding our customers and their needs. So let's dive a bit deeper into our average Cloud Foundry users at Liberty Mutual. A typical Cloud Foundry customer at Liberty is a software developer or an engineer. The average application developer using Cloud Foundry at Liberty just wants to worry about their source code and not worry about how it's running or when and why we're making updates to the platform. Hence, our favorite Cloud Foundry haiku. Here is my source code, run it on the cloud for me, I do not care how. Another example of a Cloud Foundry customer is a developer that supports many applications. They likely support additional applications outside of the Cloud Foundry runtime. They may have developed for and supported different application teams in the past. They may even no longer support an application that they were the last committer on and likely still considered the subject matter expert of. This customer likely does not have time to prioritize and understand each app's needs at the same time. Another example of a Cloud Foundry customer is a developer that supports legacy applications and migration efforts to the public cloud. Their existing running applications in Cloud Foundry are not their priority, and they don't want to have to shift priorities or worry about their running apps being impacted. Of all the running applications in Cloud Foundry, only about 62% of them are deployed frequently. Unfortunately, the reality is that some of our running workload in Cloud Foundry is not actively maintained or written in a cloud-native environment. And so having our customers migrating individual apps can prove problematic. Our priority on the Cloud Foundry platform team has and always will be to put our customers first. This means no impact to the applications or the business. And because they're likely busy working on application-specific priorities at any given time, we don't want to ask them to add work to their plate to help us migrate the platform. We're always looking at ways to communicate transparently and often as things are happening or going to happen. It's more of an art than a science, and sometimes we have trouble reaching all of our users, but we strive to reach everybody in some way, whether it be by status page updates, internal blog posts to the community, Slack posts, direct emails, and even through our approval process within change management, which requires sign-off from each portfolio on changes. We care about our customers' feedback, so we want to be able to get ideas out there early and often in order to pivot or reprioritize something based on their needs. So, with all of that said, based on all of our customers' requirements, we made a snap decision to migrate our largest foundation. With the trust and support from upper management, we decided to go big or go home. But before we get to the exciting migration itself, there are months of work to be done in preparation to confidently migrate Cloud Foundry.
Before we can migrate to a new Cloud Foundry, we need to build a new Cloud Foundry to migrate to. We used a start and wait tool called Genesis to prepackage and distribute pre-tested configuration options for Bosch manifests and custom configurations. But because we're using a new tool, the team needed to be taught how to use the tool effectively, as well as how to add any custom configurations that would be needed to suit Liberty Mutual's specific needs for the platform. The build-out required deploying more than just Cloud Foundry itself, though. We deployed several additional software stacks alongside Cloud Foundry to aid in its operation and augment its capabilities. For example, we used Prometheus, Grafana, and Alert Manager to monitor the status for the platform and alert us when something went wrong. We use Concourse to automate the platform's deployments. We use Stratos as a user front end to Cloud Foundry. And we also had to deploy Redis and RabbitMQ brokers and services so that applications on the Cloud Foundry platform could opt to use them if they so chose. One goal we wanted to achieve in order to build out a new Cloud Foundry was to deploy our Cloud Foundry foundations to the same subnets that the existing Cloud Foundry foundations that we were migrating from were in, with the hopes that by doing so, we could avoid firewall or security group related issues for app traffic.
And because of some internal security requirements, we needed to separate our new foundation components from our existing foundation. So we accomplished this by creating a new AWS account to deploy all of our new foundation components into. And since we were using the same subnets as our existing Cloud Foundry, We paired the subnets across the accounts. One of the initial foundations we built out with Stark and Wayne was a lab environment that we could learn and play in without worrying about interfering with any of our Cloud Foundry users. Using all the new components, tools, and learnings, we also needed to practice a migration end to end from our existing lab environment in AWS to our new lab environment in AWS. While practicing and learning in lab, we also spent months configuring and validating the newly built out Cloud Foundries in our customer facing foundations.
We made the decision that while we were migrating the existing Cloud Foundry, we would not yet migrate the existing data services. We saw an opportunity to decouple the migration of data services from an already complex application migration. The data services would remain managed by their brokers in the existing foundation for weeks after the application migration. So we needed to ensure that the newly migrated applications were still capable of provisioning new service instances, as well as maintaining connectivity to existing service instances. Because we're staying in the same network, no application security group changes were needed, but because we were in a different AWS account, we had to be sure to configure firewall rules to enable traffic. Infrastructure configurations aside, there were additional BOSH and Cloud Foundry configurations that needed to be made in order for the new platform to be able to locate service instances and brokers in the source platform. Redis service instances register their locations with the applications as host names that are accessed through BOSH DNS. BOSH DNS is a functionality in which the BOSH director exposes internally managed DNS host names corresponding to each VM under the BOSH director's purview, but it can only expose these host names to VMs that the BOSH director manages. Because we're migrating to a platform that's managed by a different BOSH director than the source platform, applications on the new platform do not inherently have access to the host names that the Redis broker will be exposing to them. Therefore, we had to come up with a solution for continuously merging the BOSH DNS host name entries from the existing BOSH director to the target foundation's Diego cell VMs. To implement this in the original foundation, we deployed an Nginx server that served the records file containing all of the Redis DNS host names. We then created an application that periodically checks the file served by the Nginx server for changes and can merge the remote DNS names into a local DNS records file that is managed by the target VM's BOSH agent. Once we installed this application on each of the Diego cells in the target foundation, applications were able to successfully resolve the host names of their respective Redis service instances. However, this still leaves some service components that are not resolved through BOSH DNS. The RouteMQ management API in both the RouteMQ and Redis service brokers register their DNS host names with the CFGO routers using a component called Route Registrar. In this configuration, traffic to these components enters through the Cloud Foundry Go router, and the Go router in turn reverse proxies this traffic to the appropriate component based on the subdomain of the host name in the request. Without any additional work, the Go router of the new Cloud Foundry Foundation would not know where to reverse proxy the traffic to for these service components. Therefore, we need to configure Route Registrar to tell the new Go router about how to map these routes. One solution would have been to reconfigure the existing route registrars to register routes in the new Cloud Foundry, which led to complications around configuring components across BOSH directors and traffic across AWS accounts. Additionally, because a route registrar can only register to one Cloud Foundry at a time, we would have had an extra migration step during migration day, where we would have had to redeploy route registrar components on the services during our already limited change window in order to reconfigure them. It's for these reasons that we opted to deploy new route registrars. Normally, a route registrar assumes that the IP that it's mapping to the host name it registers is the IP of the VM that the route registrar is installed on. However, this can be overridden, and it had to be because we were installing these route registrars in our new foundation to map to components in our old foundation. Additionally, any given route registrar can only map routes to a single IP, and as such, we had to deploy a new route registrar for each component we wanted to map a route to. This means we had to deploy 3 new route registrars, one for the RouteMQ broker, one for the Redis broker, and one for the RouteMQ management API.
While we built out our new Cloud Foundry foundation and configured all the missing links between our old foundation and new foundation, we attempted to communicate and document our efforts. While practicing the migration, we attempted to script and document the entire process in order to be repeatable. We created a runbook from this, in which, as we learned or discovered new practices or configurations, we were to document the steps that were taken for us to later reference at any point. We were also sure to communicate to our customers that the migration will be occurring and that they will not have access to deploy during the window that we are migrating. At this point, we feel confident that if anything unexpected happens during the migration, which we know will happen because we have not yet been exposed to the sheer scale of our largest foundation with the real workload, we'll be able to address it during the migration itself. We plan for our migration window to consist of 4 major phases: prevent any customer changes to the foundation, clone Cloud Foundry state to the new foundation, verify that everything is ready to go live, and then actually flip the switch. Based on our learnings from lab, we estimated that if everything went according to plan, then the migration in its entirety should take us about 4 to 6 hours. Because of the risks involved with the migration, we were to make any impactful changes to DNS during a coordinated window at 2 a.m. This gave us several hours in our change window before the impactful change timeframe to migrate the data and perform our platform validations. Once the DNS change occurred, we allotted 2 hours for application teams to validate their own applications are running as expected on the new Cloud Foundry.
A change freeze is necessary for this migration because any changes that a user can make after we take a snapshot of the platform data would be lost after we restore that data to the new platform. The change window needed to be long enough for us to take a snapshot of the data and then import it into the new Cloud Foundry and then cut the DNS over. Changes to the platform consist of app deployments, creation of new artifacts, and really anything else you can do to the platform as a user. We prevented these changes by stripping away users' authorization to make changes through removing space developer access to the source foundation. Now that we've ensured that customers cannot make changes to the foundation, we can confidently migrate Cloud Foundry. To copy Cloud Foundry's blob store, we performed an S3 sync from source to target, which we can perform prior to the migration window so that there's less data to sync when we snap during the migration window. The initial sync that we performed prior to the window took over 10 hours, but when we performed the final sync during the change freeze, it only took a few minutes to complete. To snap the databases, we did a MySQL dump of all Cloud Foundry databases from the Cloud Controller API VM and copied over the dump file to a Cloud Controller API VM on the target Cloud Foundry. We then imported the dump file to all target Cloud Foundry databases. While this is arguably the entire data migration, the process in total really only took about 15 to 20 minutes. The time it takes to start up the target Cloud Foundry and the attention to detail we put into validating the target platform is where the bulk of our time was spent during the migration window.
Once the data was successfully migrated, we started Cloud Controller and Diego back up and then restarted all the Diego cells. This took a considerable amount of time because of how many Diego cells we had. Once the target foundation was started, we could start validating the platform. The team divided and conquered the various validations of the platform according to their area of expertise. We started comparing all Cloud Foundry metadata between the source and target Cloud Foundries, which included monitoring the desired LRP count and the running LRP count in order to understand if there was crashing apps in the target foundation. Also monitoring the Diego cell capacity because we were using this migration as an opportunity to right-size our Diego cell allotment, and running platform smoke tests to ensure the platform was still healthy with the new workload, and also using validation applications that were intended to help us identify any problems with particular build packs or connectivity to data services. Assuming all validations were successful, we now had to wait to enter our impactful change window at 2 a.m. to cut over to the new Cloud Foundry. Cutting over to the new Cloud Foundry was handled by changing a single A record. Every ingress hostname to Cloud Foundry was changed to be a CNAME record pointing to this single A record before the migration began. Cutting over also required us to shorten DNS TTLs and cut connections to the old load balancer so that all connections would be forced to reconnect to the new load balancer. By having the DNS team help us change every hostname to be a CNAME record pointing to a single A record prior to the change window, we were able to perform the cutover independent of other teams. Because of how many URLs we managed, this simplified the work needed to be done during the actual impactful change window at 2 a.m., which significantly reduced the risk and time for our team. Once DNS is cut over, our new Cloud Foundry is live and we can begin to shut down our old Cloud Foundry. Is what I would have said had everything gone according to plan. However, during our first attempt to migrate, we had a few failing validations. Smoke tests were not consistently passing after the initial migration, which we knew meant there was potentially a problem at the platform level. And we also noticed a large discrepancy in running apps, or LRPs, between the source and target foundations. We couldn't identify the specific apps that were crashing with the monitoring we had in place, at least within the time our change window had left. So it was because of these two impediments we ultimately made the decision to roll back in order to allow ourselves time to dig into the problems a bit further. It took us 3 separate migration windows to successfully migrate with 2 rollbacks. The decision to roll back was difficult as we were actually over 12 hours into the migration window at the point we had decided to roll back. So much for our estimate of 5 hours. We were emotionally invested in completing the effort that we had spent so much time configuring and coordinating, but ultimately it was the right decision to make every time we chose to roll back. We had a go, no go decision point identified prior to migration day, which allowed us to do validations prior to any of the impactful changes that the DNS cutover would introduce. This allowed us to roll back without any impact to the applications or the business. Had we not communicated the change as widely as we did, our customers would have had no idea anything even occurred. We actually received feedback that we should have communicated the rollbacks better. Some app teams assumed we were successfully running an open source the Monday following our rollbacks. We wanted to be as transparent as possible with customers and stakeholders. So the week following each migration attempt, we posted a lessons learned post to our internal blog. And we actually received lots of positive feedback on the decision to roll back from customers and management, calling the failed migration attempts a success. With each rollback, we discovered we needed better data. We built a network tester that identified all egress traffic destinations, which we provided as endpoints to an app that we deployed to the foundation we were migrating. The app then attempted to hit these endpoints in order to identify any unreachable network paths. We also put better platform monitoring and metrics in place specific to the migration to help us identify the apps that were crashing with their crash events in the target foundation, but seemingly fine in the source foundation. Both of these data points helped us to identify similar patterns that may be causing the discrepancy in LRPs and what applications we could look at that were specifically preventing us from confidently migrating Cloud Foundry. So here we have the existing metrics from our initial attempts to migrate on the left from a few slides ago, and some of the improved metrics to help us identify crashed events of specific applications on the right. This additional info identifying the app GUIDs was one of the improvements to the metrics that helped us to look into the application logs and identify what the problem could be. Now that we have a better data and an idea of what a migration looks like in our largest foundation, how can we best set ourselves up for a final successful migration? We had the idea to perform what we called a dirty snap, where we could basically copy the application data from the workday in a dirty state from a specific time in order to have both Cloud Foundries running with real workload, which would help us identify any problems before we enter our next change window. This was helpful in building confidence that we've ironed out all the details. We warned our customers that they would be seeing duplicate instances during the workday, but that their in-flight activities and priorities would not be impacted. Our third attempt to migrate was ultimately successful thanks to our better data to identify patterns and our dirty snap attempt that identified our biggest blocker, which I will talk about in a minute.
During our early migration attempts, we discovered a few problems that were not major blockers for us, but that caused concern. In the version of the platform that we initially deployed to the target foundation, there was a logging component that had a regression where it was not keeping up with the log volume of the applications that we were migrating. This was the reason for the failing platform smoke tests. Also, the build packs that we initially migrated over were being overwritten in a later stage of the migration by online build packs because we had forgotten to alter our deployment manifest to not see these build packs anymore. That was easy enough to fix on migration night, but it did cause some confusion and lose us some time. But before we identified what our biggest blocker was, we noticed several RDS instances that the applications were using were shut down. Liberty Mutual has a service that shuts down applications and resources such as databases in our non-prod environments off hours in an effort to reduce costs. We assumed that some of the migrated applications could not start without connectivity to these resources that were brought offline, so we would later reach out to the public cloud team to disable this service during future migration windows.
However, none of these reasons we mentioned ended up being the underlying cause for the app crashes that led to our decisions to roll back. Now that we had the metrics to identify the crashing apps, we were well positioned to dig into the application logs for these failing apps. And what we saw across the board were timeouts connecting from the target Cloud Foundry to AWS resources such as RDS instances. From here, we dug into the application CFTs where these RDS instances lived and identified some of their ingress access rules were using a security group. If you remember from a bit earlier, we had deployed our new Cloud Foundry foundation in a separate AWS account in order to comply with internal security. The security groups used for these RDS instances are account specific, so they weren't working as designed in the new Cloud Foundry. In order to successfully migrate all Cloud Foundry applications to the target foundation, we decided to temporarily deploy the Diego cells into the old AWS account prior to our third attempt. This allows the external AWS resources using security group ingress access rules to successfully be accessed by their respective Cloud Foundry applications. Today, we are working with application teams to update their external AWS resources access rules to use a new security group that is defined in both AWS accounts we are using. In the near future, we intend to deploy the Diego Cell VMs into the new AWS account with the knowledge that all Cloud Foundry application dependencies are using access rules that will work. We had nothing but support from application teams and management throughout the weeks and months of the migration attempts. Our own team doing the work truly supported each other throughout the weeks and long weekend nights as well. Every member of the team played a key role in successfully migrating Cloud Foundry. Each failed attempt and rollback was positively praised as successful due to several factors. By being transparent about the challenges we faced and lessons we learned alongside each attempt, it proved we are a trusted team and partner within Liberty Mutual. By prioritizing the customer rather than rushing to complete the migration, we were able to successfully complete the migration with no impact to the business. And lastly, by performing the dirty snap during working hours and with the majority of the migration happening before the impactful change window, we helped to shift the culture of change management within Liberty Mutual. We've migrated, hooray! Now what? Now we reap the benefits. By migrating to open source, we gained a significant amount of savings in licensing costs because we like to be on brand with Liberty Mutual marketing where you should only pay for what you need. We also now have all of our configurations as code, which means all configs and change history is managed in Git. It's easier to stand up new Cloud Foundries in order to offer new foundations and regions to our app teams now, and we also have access to override individual platform components to suit our requirements at any given time. We both kind of touched upon the platform automation and monitoring that we configured and learned prior to migrating. Not only did it help us during the migration, but we continue to benefit from it today. We're using Concourse, which allows us to easily and more frequently upgrade CF, patch AMIs, recreate container instances, and rotate credentials, amongst other things. And with Prometheus, Grafana, and Alert Manager, we now have better alerts and visualization of all our platform metrics. While this was a huge and at times daunting undertaking, the benefits of where we are today made the decision well worth it. With the success and confidence of this migration to open source behind us, Liberty Mutual is starting to evaluate other technical areas that can potentially migrate to open source as well. Thank you for listening to our talk.
Thanks.
Join. Cool. Hi. I should start out by saying overall, it took us about a year to migrate all of our foundations to open source. And immediately following that, we were able to stand up a new foundation for our users with quick turnarounds, as well as start running through the upgrade process and seeing how everything works. And it's been a really fun year with Stark and Wayne. So I guess let me know if you have any questions. Tom's trying to join. Great question, Rich. How long do you think it would have taken to migrate if we went with the new city approach? We'd probably still be waiting on customers to deploy to the new city. And we're over a year at this point since we started. So I'm assuming it would have taken double or triple the time, if it even would successfully be complete by any point. Tom, what do you think?
I think I had two windows open, so you were talking over you talking over you talking. So let's try that again. If you wanted the new city option, I think that it would have. I think it actually wouldn't have taken as long from the amount of work that we had to do. But I think that given uh, the sort of landscape at Liberty Mutual, that we probably would have run into a lot of blockages with waiting for people to do the things they had to do, as far as your customers on the platform. Yeah.
Agreed. Oh, Rich, another great question. Yeah, we kind of skipped over the data services migration itself because that could be its own presentation on its own. But we did successfully migrate the data services uh, pretty much right after we were done with all of the applications in AWS. We did the data services for all of them, and then the same with all of our on-prem.
I think in the first environment we did it, it was like a month after, but like every subsequent environment, we were doing it like the next week or so. Once we felt that we knew the platform was stable. Can you give us an example of configurations overrides that you now make that you could not do in the non-open source foundation? Well, you know your non-open source foundation better than I do, so.
Well, for instance, we were recently going through a CF upgrade, um, and we realized that the version of GoRouter that was with the CF upgrade was causing a few applications to have problems. So we were able to individually go in and update the GoRouter and roll back just the GoRouter, but keep CF and everything else in place as was. So we rolled back just the GoRouter, which we wouldn't have been able to do had we still been using a vendor. Another good question.
Yeah.
So I would say we treated each foundation as its own migration, and I can confidently say that if we were to migrate one more foundation, we would still learn something new. It was a process, a learning process every single time. I feel like we got better and more confident with ourselves each migration. But yeah.
Yeah, I think that like the brunt of the learning was in the first two foundations we did, though. Like there was probably little things in each individual one, but like the first one we learned a ton, and then the second one was like, oh God, people have configured their autoscaler differently. I didn't plan for this. Shoot. How clear it is more the flexibility in combining the versions of components.
Yeah, exactly, Harry.
Yeah. Granted, it is technically stuff that you could still do with the tiles under the hood. It's just that the tiles and the ops man start to try and get in the way because they want to provide to you the blessed tested experience, which makes sense. We were going to talk more about the data migration in the talk, and then we timed the amount of content we had for a 30-minute session and found that we did not have time to talk about the services, because that we could have easily gone on for another 20 minutes about those. Just sad, but I think the short version of it is that RabbitMQ, we could migrate all of the vhost and queue configurations by essentially adding more nodes to the cluster on the destination that we wanted to migrate to, and then cutting out one by one the old parts of the cluster, so that effectively we're just like using the quorum to just have RabbitMQ fix itself every time we made a node until all that was left was in the migration target. And Redis was pretty conceptually easy because Redis is a cache, and for the customers at Liberty Mutual, we expose it as a cache. If you're using it as a database, then shame on you, sort of thing. And so
Yeah, we never promise HA or anything. So
more so, there's always the whereas we try not to ever lose the cache. We never promise that during an upgrade the cache will persist per se. So it was mostly a matter of making sure that they always had a cache to point to, and less that we had to actually migrate the cache data, which is a thing you can do. It just would have been a whole ordeal to do it on the scale that we would have had to do it.